Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about the circles and the equations of the circles. We're going to also discuss about how to draw the circles using the equations and how to get the equations of the circles from their graphs. So I would like to start this video about how to define the points on the rectangular coordinates and how to find the distances between them. So let's say I've got 2 points on the rectangular coordinate system with the corresponding coordinates x0, y0, and x1 and y1. And if I would like to find the distance between them, then I need to use the following formula. So essentially, the distance between these 2 points is going to be the difference between the coordinates, the y coordinates, the, the difference between the y coordinates of these points, the difference between the x coordinates of these points, their squares, their sum, and take the square root. So let's do an example. So in order to find the distance between these 2 points, so let's say the points are given with the following coordinates, -3 and 1 for the first point, and 2 and 3 for the second point. So what I would like to do is the distance is going to be equal to the square root of. So I need to subtract the x coordinates first of all. So please note that it doesn't matter which point you're going to take the first one or the second one. In both of the cases, you're going to get the same result. So essentially, let's make this as the first point, and this is going to be the second point. So the 2 minus 3 in the square plus, so then I need to subtract the corresponding y points. It's going to be 3 minus 1 in the square. So essentially, if you take the square root of the sum, it's going to be 2 minus 3. It's plus 5, right? 5 in the square is 25, plus 3 minus 1 is 2 in the square, it's 4. Then this is going to be equal to the square root of 29, which is the distance between these 2 points. So now we are going to define the circles in this way. So let's first of all define what is the circle. So the circle is set of all points which are equidistant from a point which is going to be called as a circle. It's the center of a circle. So essentially, let's assume that I'm going to take this point at the center. So this is called the origin point, where the x coordinate and y coordinate of a point is equal to the 0. Then I would like to just take one point Q with the coordinates x and y. So I would like to measure the distance. Okay, so let's assume that distance is equal to the 1 or 2. It doesn't matter what is that distance. Then what I would like to do is I would like to find all of the other points which are in the same distance from the origin. So in order to do this, one of the simplest way would be to just like rotate this arrow around the origin, right? So in order to find all of these points. So let's do this. So you see, so if I will just rotate this arrow around the center, I will actually reach all of these points which are far away from the center in the same distance. So I'm going to call this distance as the radius. So again, it's really important for us to understand that the circle is just the set of all the points which are in the same distance from the origin. And if you remember, we used to find the distance between these 2 points using the formula, right? So do you remember this? So let's say I'm given 2 points now, origin and any point on the circle. So you can choose any point. For example, this point was the coordinates x and 0. And the distance between them is going to be the subtraction of their x coordinates, right? It's going to be simply x in the square. Subtraction of the y coordinates, it's going to be simply y in the square, right? And this should be equal to the distance between them in the square. So essentially, this is we are going to define as the equation of a circle. Okay, so here it is. So now let's do the graph of a circle. So just an example. So let's say we are given this equation. So this equation corresponds to the circle, right? So it tells you that hey, the distance between the 2 points, the point was the coordinates x and y, and the origin is equal to the 2 in the square. So essentially, this 4 can be written as a 2 in the square. And if you remember, the equation of a circle was the center at the origin. So that constant in the right-hand side part represents the square of the radius, right? So this 4 is essentially the square of the radius, or this distance between all of the points and the center of a circle. So in this case, the radius is equal to the 2, so that's why I'm going to draw this in this way. So let's say this point is going to be equal to the minus 2, this point is 2, this point is 2, and this point is minus 2. And if I would like to just draw all the points which are far away from the origin at this point, at this distance, at the distance of 2, right? Because this distance is equal to the 2, right? Then I just need to rotate this arrow around the origin, and I will get roughly this square. So this square corresponds to this equation, okay? So we would be interested to know now, so is it like circles always have a center at the origin, or we can just move them? So essentially, so moving the radius or just making the circle bigger or smaller is just a matter of changing the radius. So essentially, if this equation would be given as x in the square plus y in the square is equal to the simply 1, it would mean the similar circle. The circle was the center at the origin, and it was the radius is equal to the 1. So the circle is going to be just a half smaller than the circle. Okay, so you see, so this radius is essentially is going to define us how big the circle is. So now what we would like to do is we would like to move the circle to the right, or to the left, or to the up, or to the bottom. So in order to do this, we need to change the center, right? So the center from the origin should be moved to a certain point with the coordinates A and B. So let's say I'm given 2 points. So the Q point was the coordinates X and Y, and the C point was the coordinates A and B. So the C point is going to be now the center of a circle. So if you remember how we find the distance between the points, right? So it was like essentially x minus a in the square. So essentially the x coordinates of these points, right? So subtraction of the x coordinates of these points plus y minus b in the square, right? Subtraction of the y coordinates. So essentially y coordinate of this point is y coordinate of this point is b, so I need to subtract them and square them, right? Take the square root, and this is going to be equal to the distance, which is the radius, right? Or if I just would square both of the sides, it would be simply radius in the square, okay? So essentially, I'm interested to find all of the points, right? So you see, so whenever I say that a Q has the coordinates x and y, so this point might be here, or this point might be here, or here, or here, right? Any point is going to satisfy this equation because the distance between this point, for example, this point here, or the distance between this point or this point and the center is always going to be the same, right? So this is the measurement of the distance between the points, right? Good. So then what I would like to do is, so this is going to be the equation of a circle. Now, I will just like rotate this arrow again around the center in order to find all of these points which are in the same distance from the origin. So let's do this. Right. So this is the circle now again, and the equation of the circle was the center at the point A and B is going to be different than the circle was the center at the origin, right? So this is what does it mean? So I've got this equation, okay? So in every time, if you're given the equation of a circle like this, you need to know that, hey, this is the circle was the center at the point A and B. So sometimes it is a little bit confusing on whether you need to choose the plus A or minus A. So one way to make your life easier on identifying the center of a circle is that just substitute X with the value of the plus or a minus A. For example, if you would just substitute minus A to here, what you get is minus A, right? So just instead of X. So which doesn't make that 0. Okay, so you need to put here x to be equal to the a, and now if you would just put this x is equal to the a to here into this x, then it makes like a minus a, which is going to be simply equal to the 0. So you need to always choose the value for the x, a number, which will just make a corresponding square to be equal to the 0. This is how we are going to identify the center of a circle. So let's do an example. So let's say we are given this equation. So x minus y in the square plus y plus 1 in the square is equal to the 1. So again, if I would say, hey, could you please tell me first of all, what is the center of a circle? You need to again choose the values for the x, okay? So if x would be equal to the 1, then this bracket would be equal to the 0, right? And if y would be equal to the minus 1, then this bracket would be equal to the 0, okay? And again, so in order to identify the center of a circle, just try to choose the values for the x and y, which would make those squares to be equal to the 0, okay? So in this case, the center of a circle is going to be at the point 1 and minus 1. So it is somewhere here, right? So this point is, so, oh, is it like, okay, so the x is 1 here, and y is minus 1 is here, right? So this is going to be this point here. Sorry. So now I need to look to the right-hand side part. This is the square of the radius, right? The square of the distance between all the points and the center. And it's equal to the 1, so that is why the radius itself is also equal to the 1. So it makes my life easier to draw a circle. So the circle is going to be at the center at this point. So this is going to be the center of a circle. Now, in order to draw the circle, I need to just like find all the points which are in the same distance, right, from the origin from the center of the circle. So for example, this distance is equal to the 1, this distance is equal to the 1, this distance is also equal to the 1, right? So any point, the distance between any point and the center is equal to the 1, to the radius. So that's important point to define the equation of a circle. Cool. So you see, so when you're given the equation of a circle in this form, like x minus a in the square plus y minus b in the square, then that's kind of easy for us to sketch the graph of a circle to identify what is the center and so on. But usually the equation of a circle is going to be given differently. Okay. For example, your equation of a circle might be given like this: x minus 1 in the square plus y plus 1 in the square is equal to the 1, which makes very much clear where is the center of a circle, right? So by just looking to this, I know that the center is going to be at the point 1 and minus 1. But what if I would just expand all of the brackets, right? So we know that there is a formula x plus a in a square, which can be expanded as the x in the square, so essentially the first term in the square, plus 2 times the first term in the second term, plus the second term in the square. Okay, so let's just apply this for this bracket. So it's going to be x in the square, so let me write it. So it's going to be x in the square, the first term in the square, right? So in this case, it's going to be minus 2x1, okay, so x times the 1 is simply 2x, plus minus 1 in the square, which is going to be equal to the 1. Okay, so I'm going to try to do the same thing for the second term with the y. It's going to be y in the square plus 2y plus 1, and this is equal to the 1. So now if I would just like simplify everything out, then it would be like an x squared minus 2x, right, plus y in the square plus 2y is equal to the minus 1, right? Because this one and this one are going to be canceled, and this one goes to the right, it's going to be simply minus 1. So this equation is also equation of a circle, but I don't see this from this point, right? So essentially our goal is not to expand this form of the equation, not to expand this form of this equation in order to get this, the white one. So our goal is essentially to get the yellow one from the white one. And one way to make it is to again just make all of these equations in a compact form to bring them in a complete square form. Okay, so let's do a couple of exercises. So let's say we are given this equation x squared minus 10x plus 18. So if I would just bring, so of course this is not an equation of a circle, so I just would like to bring this equation into the complete square form. So I would like to write this as a x plus minus a in a square plus some constant maybe. Okay, so in order to do this, the idea is always like this. So I would assume it's like this. So x squared minus, so you need to always write down this as a 2x, always. No matter what is the term with the with the x, so you need to always put there 2x. Okay, so now I need to make this 2x to be equal to the 10x because this is 10x here, right? So I'm going to multiply this to the 5 because in this case it's going to be minus 10x, right? So do you remember this formula? So in this formula it was x squared, then 2x is coming, right? Then multiply to the I. So a is in this case is going to be minus 5 essentially, right? I can figure this out from here. And plus the square of the a. Okay, so I'm just going to add plus 25. Just just make this to be equal to the complete square. Okay, so since I added 25, I'm going to just subtract this as well because yeah, so it's a constant. I can do this. And additionally to this 25, I used to have 18 as well, right? So plus 18, and this is equal to the 0. Okay, cool. So this term, the first three terms, can be written as the x minus 5 in the square. So indeed, if you would just expand this, you would get the same term, right? And minus 25 plus 18 will bring you to the minus 7 is equal to the 0. Okay, you see, so if your equation is given like this, which is an expanded form, you can just like make it smaller, make it compact, just using this formula again. So essentially, if the equation of a circle is given, for example, in this form, so x squared minus 4x plus y in the square minus minus 6y probably. Here's a typo, 6y plus 9 is equal to the 0. So now you see, so I need to make the complete square form for the values of the x, for the x term, and for the y term, okay? So, and again, we're going to use the same technique. So essentially, so it's going to be x in the square minus 2x, always, okay? So times to the 2 because I have to make it to be equal to the 4, right? Plus this 2 in the square, okay? Plus 4, okay? So let's do the same thing for the y. It's going to be y in the square minus 2y, okay, because of this formula. So now I have to make it 6y. In order to do this, I need to multiply this to the 3. And just after the 3, it should come the square of the 3, okay? So I'm just going to, so I just added this 4 and 9 to just make it complete square. So I'm going to just subtract them, minus 4 and minus 9, okay? But additionally, I used to have 9 as well, right? So 9, I'm going to write all of this term here. So I hope that you are understanding what is going on. So instead of this 2 terms, I wrote this 4 terms. Instead of this 2 terms, I wrote down this 4 terms plus the 9. Okay. So now what I have is essentially the first 3 terms here are making the complete square. So this is going to be x minus 2 in the square, right? And this first three terms here are making again the complete square form. They are making y minus 3 in the square. Okay, now if I just add up all the constants, it's going to be minus 4, minus 9, plus 9, it's going to be equal to the 4, or minus 4. If it goes to the right-hand side part, it is going to be equal to, sorry, it's equal to the 0, okay? So if I just put this minus 4 to the right-hand side part, it's going to be equal to the 4. So essentially, it appears here, we were given the equation of a circle, right? It was the center at the point 2 and 3, and it was the radius to be equal to the 2, it appears, which you don't see from here, right? So you need to try to bring these equations of the circles always to this form, or to the complete square form, in order to see where is the center of the circle, what is the radius of the circle, and so on. So, okay. So the last thing which I would like to discuss with you is how to find the equation of a half a circle. So it appears whenever you are given the equation of a circle in this form, x squared plus y squared is equal to r squared, this is not a function, right? So there used to be a test to define whether this is the function or not, and the test tells you essentially, hey, if you are able to draw a vertical line which is going to intersect with your curve more than once, then this is not a function. And we can do this kind of vertical lines a lot, right, for the circle. So essentially, I can just draw this circle, this vertical line, and again, it's going to intersect with the curve of the circle more than once. Then this is not a function. So what we can do in order to make this circle is to just split this, or make the circle to be a function is just to split this into the two parts, essentially the upper half and the lower half. They separately are the functions, but together they are the functions. So in order to find essentially the equation of the upper half or the lower half, we need to essentially find the y from here. Okay, so if you would find the y from here, it's going to be y in the square is equal to the r square minus x square, right? And the y is going to be equal to the plus minus square root of r in the square minus x in the square. Okay, so essentially, you're going to get two roots, right? So if you just take it, y to be equal to the plus square root, it's going to be just the equation of a half a circle. If you take it, y to be equal to the minus square root of r squared minus x squared, it's going to be the equation of a lower part. So let me show you what I mean. So essentially, if you would like to draw the upper half of the circle, it's going to be r squared minus x squared. If you would like to draw the lower part, you need to take it with the minus here. Okay, so at the same time, we can figure out the equation of the two other half of the circles, right? So we can define the circle as the left half or the right half. And in this case, again, we're going to use the equation of a circle. But in that case, I'm going to find the x from there. So essentially, so let me write this one more time. So the equation of a circle was the radius r and the center at the origin is equal to the x squared plus y squared is equal to the r squared. So I'm going to find the x squared from here. It is going to be equal to the r squared minus y in the square, right? So it leads to the equation that, hey, either x is equal to the plus square root of r squared minus y in the square, either x is equal to the minus square root of r squared minus y in the square, right? So essentially, for this case, it doesn't matter what is the y, whether y is positive or negative. X is always positive because you're taking the square root of the number, right? So essentially, all of these points here on the right-hand side part, have positive x coordinates. So if you would just write down the general coordinates of all of these points here, x is positive here for all of these points. And essentially, if you would like to define the circle with on the left-hand side, you need to take this equation like this. So x is going to be equal to the negative square root of r in the square minus y in the square. So in this case, for all of these points along this curve, along this left half circle, the points are going to have the negative x values. So essentially, if you would just denote these points x and y, then x is negative for all of these points. And you can see this from this equation, right? So you're taking the square root, which is going to be a positive number, and you're multiplying this to the minus 1, which makes it negative. So let's do a couple of exercises to define the half of the circle. So essentially here, so for this example, we need to find the upper half of the circle. So how we can do this? So do you remember upper half means that your curve should be defined as a y is equal to something, right? So I'm going to find the y from here. So in order to do this, I'm going to find y minus 1 in the square is equal to the left half. So let's first of all find the upper half, then we can find the left half. So y minus 1 in the square is equal to the 36 minus x plus 2 in the square. Okay, then I'm going to take the square root from both of the sides. It's going to be y minus 1 is equal to. So essentially, if I would like to find the upper half, I need to take the positive square root. Okay, so this is going to be square root of 36 minus x plus 2 in the square. Okay, and if I wanted to find a y, then this minus 1 should go to the left-hand side, to the right-hand side, right? So let's do this right immediately from here. So I'm going to try to do this. So essentially, if I would just find a y from here, it's going to be a square root of 36 minus x plus 2 in the square plus 1. Okay, so upper half, it means that y is always positive. Okay, so you need to think about what is always positive or negative. So whenever we're given the task to find the left half, it means that x should be always negative, right? So you see, so on the left-hand side circle, y can be positive or negative, so positive or negative, but the x should be always negative. Okay, so essentially I need to find the x from the equation of a circle. In order to do this, I'm going to just put the y y terms to the right-hand side part, it's going to be x plus 2 in the square is equal to the 36 minus y minus 1 in the square. And again, if you take the square root from both of the sides, you can write this as this plus minus square root, right? So what you're going to do is you're going to take it with the minus square root because x should be always negative, okay? So I'm going to do this x is equal, or x plus 2 is equal to the negative square root of 36 minus y minus 1 in the square, okay? Then you see, so this 2 should go to the left so that you can write it as the x is equal to something, right? So this is going to be x is equal to the negative square root of 36 minus y minus 1 in the square from the square root minus 2. So this is going to be the equation of a left half circle, and this is going to be the equation of a upper half circle. So this is how we are going to define the equations of a semicircles. And also we've learned about how to define the equation of a circle, how to find the center of a circle and the radius of a circle, how to bring the equation of a circles into the complete square form and identify those parameters of the circles. So I hope that this video was helpful for you. Thank you very much for your attention.